morning, students. Now in this class, we introduce a new method. That method is called a partial fraction. So this partial fraction is involved in the another one chapter is also. In integration also we use this concept. So first I explain a partial fraction. So first we see some easiest sums. So next we move this partial fraction sums. That is, some terms are given. Directly integration formula is not possible. Suppose we split the given term, then there is a chance in integration formula. So the partial fraction is useful in integration also. So many types is there. I will introduce one by one. First of all, the type 1. Suppose the term in numerator is x, denominator is x plus a and x plus b. You see, our numerator is x and denominator is a 2 factor, x plus a and x plus b. So this partial fraction is possible only when the given fraction is a proper fraction. You know what is meant by proper? The degree of the numerator should be less than the degree of the denominator. It is called a proper. You see, the degree of the numerator, degree means a variable power, just 1. Denominator variable power, we multiply, suppose x into x is x square, power is 2. So this is proper. So partial fraction is possible only when the given fraction is proper. Okay. How to write? Each and every linear factor one constant. So first, what is the factor? X plus a. So I have the constant a. So a by x plus a. We introduce the symbol is plus, we partial split plus second linear variable is x plus b. So the constant is x plus b. Suppose the factors are simplified, it's a linear factor. Each and every linear factor there will be a constant. Then we cross multiply, then we find the value of a and b. So we use the concept in the integration and we know how to find the value of the constants a and b. So it is the first step. All are linear factor. So each and every factor there will be a constant. Suppose I have one more example. X plus 5. In denominator is x minus 1, x plus 2 and x plus 3. So is an example. So each and every factor there is a constant. So what is the first factor? X minus 1. So a by x minus 1. Plus second factor, x plus 2. b by x plus 2. Plus third factor, x plus 3. c by x plus 3. Then we cross multiply, okay, or the LCM. The denominators are cancelled, then there is a chance to find the constants a, b, c. So how to find the constant a, b, c? In the next sums, in integration, we see one by one. First we explain the types. Suppose the term is of the form, each and every linear factor there is a constant. So is the first type. And the second type 2 is a repeated. Suppose the numerator is suppose x plus 2 and the denominator is x plus 5 into x plus 3 the whole square. Is also a proper. I say it is a proper fraction because the degree of the numerator is 1 and the degree of the denominator is 3. We expand, x square is another one x into x square is x cube. So it is also a proper. So, but it is a repeated factor. Okay, x plus 3 the whole square. How to write? First, one individual factor is that x plus 5. So we write it is a divided by x plus 5 plus second x plus 3 the whole square is there. So first we leave this power, we add one constant b divided by x plus 3. Okay, x plus 3 the whole square. First we write x plus 3. Next, c divided by x plus 3 the whole square. So we increase the powers. So I already tell each and every linear factor there is a constant. Here how many factor? 3 factor, because square is there. You see 3 constants. A square or cube is there, so it is a working rule. Suppose cube is there, how to write, sir? So you increase 1 by 1. First we write x plus 3. Next we write x plus 3 the whole square. Next plus d divided by x plus 3 the whole cube. So it is a working rule. Suppose the factor power is 2, 3 like this. Next type 3. X plus 2 divided by x minus 1. Suppose is of the form. I already tell each and every linear factor there is a constant. You see R is a linear factor. So it's also a linear factor, but it is not a linear factor. It's a quadratic polynomial. You see x square. Or also we can't split. Suppose minus is there is a chance. X square minus 1. We write x square minus 1 as x plus 1 into x minus 1. But it is x square plus 1. So how to write in this model sums? Whatever it may be the numerator, we always write first of all a divided by x minus 1. A divided by the first linear factor x minus 1 plus x square plus 1 is not a linear factor. Okay, it's a quadratic factor. We can't split also. Suppose in this sum, the model sums, how to write? We already write the constant a. So what is the next constant actually? B. So bx plus c divided by x square plus 1. Suppose we can't split the linear factor. It is a quadratic factor. How to write? One constant, the variable plus c. We already write here a, so I write bx plus c. Suppose another one factor is there, so I already write b. Next we move the constant cx plus d. The factor is not a linear, it is a working. So it is the third type. And the fourth type. Suppose x cube divided by x plus 1 into x plus 2. You see, it is called an improper fraction. Why? The degree of the power is 3. And the degree of the denominator x into x is x square. Okay, is 3 and it is 3. So it is called an improper fraction. So how to possible, sir? How to solve? The first step is to convert it in proper. Convert in proper fraction. There is a working rule is there. We divide the numerator divided by the denominator. Suppose we divide the numerator divided by denominator, there is a chance the improper fraction to proper fraction. So first to convert the improper become a proper, then we do the same work. Okay. So in partial fraction there will be a 4 types. So totally 4 types. What is the first type? Each and every linear factor. So each and every linear factor there is some constants. And the second one is a repeated factor. And the third one is a quadratic factor. And the last one is the improper fraction is given. To convert the improper fraction as a fraction, then to continue the work is same. So these 4 types is very important. So first you memorize these 4 types. Actually is a formula. Next we see this one. The question is same, just you evaluate or integrate the term with respect to x. Actually we find integrating of x plus 1 divided by x plus 2 into x plus 3 into dx. So now we integrate the term. You see the denominator is a product of 2 factor. Okay, so we can't split. Suppose plus minus is there is a chance to split. But is a product of 2 factor, but we integrate. Suppose we multiply inside, there is some quadratic factor. So there is a direct formula is not there in this integration. So we solve this problem by using a partial fraction. Very important in the question. using the partial fraction, the word is not there. Just integrate the following with respect to x, or just evaluate is the question. So now we have an idea. Using the sum by partial fraction, then there is a chance to split the denominator. Suppose we split the denominator, and numerator is also vanished. 1 divided by x. You know the integration formula of 1 by x is log of modulus x. So now we solve this problem by using the partial fraction. Now I consider in partial fraction term. Now we can't have an integration. First of all, we split the given term, because directly there is no formula of this integration. So I consider the term of the given sum, x plus 1 divided by x plus 2 into x plus 3. In partial fraction we use, you see it is the first type, x plus 1 divided by x plus 2 into x plus 3, two linear factor. Okay, and also it is a proper fraction, because the degree of the numerator 1, degree of the denominator is 2. So what is the first type? Each and every linear factor there is a constant, a divided by x plus 2, first factor over. We insert the symbol plus. Second factor is the, so b divided by x plus 3 is the second one. So is the first step. In partial fraction, individual factor is given. Each and every individual factor there is a constant. Here two factors, so I add two constants. Now we use this value, so I put it is equation 1. What is the next step? The next step to find the value of these constants. We introduce the constants a and b. The next step to find the value of the constants a and b. In RHS you see there is two terms, and also two term denominators are differ. So it's a single term, so cross multiplication. All the process is done by to find the value of these unknown constants a and b. So x plus 1 divided by x plus 2 into x plus 3 is equal to a of x plus 3 plus b of x plus 2 whole divided by x plus 2 into x plus 3. Now we cancel this term. RHS and LHS, both the denominators are same. So I cancel the denominators. But numerator is as it is. What is the numerator of the LHS? Is x plus 1. The numerator of the RHS, so the numerator. So x plus 1 is equal to a of x plus 3 plus b of x plus 2. I put it is a second equation. Why sir we put it as an equation? We find the unknown constants a and b. So I put it is a second equation. Now we replace any values of x. Here a, b, 2, 3, 1 are constant. X is a variable. We need the constants a and b. So it's your choice. We put the suitable value of x to find the constants. Suppose I put x plus 2 is there, so minus 2. Whenever x is there, we replace x by minus 2, because we need the constants a and b. So depending upon the given sum, the value of x can be changed. So I eliminate b and I find the value of a, so I put the value of x is minus 2. So minus 2 plus 1 a of, whenever x is there, we replace x by minus 2. Minus 2 plus 3 plus b of minus 2 plus 2. Minus 2 plus 1, minus 1. A of minus 2 plus 3 is 1. Plus b of minus 2 plus 2 is 0. b into 0 is 0. Minus 1 is equal to a. What about a? Minus 1. So the value of a is minus 1. So we find the value of the constant a. Next, to find the value of the constant, this b. Now you have an idea? So x is minus 2, we put b is vanished. We put in which value of x? A is vanished. X plus 3 is there. Suppose we replace x by minus 3, a is vanished, b is possible. So put x is equal to minus 3 into. In second equation, fully, I replace x by minus 3. Start from x. So minus 3 plus 1. So minus 3 plus 1 is equal to a of x plus 3. The value of x is minus 3. Minus 3 plus 3 plus b of the value of x is minus 3. Minus 3 plus 2. Minus 3 plus 1 is minus 2. A of 0 plus b of minus 3 plus 2 is minus 1. Leave it. Minus 2 is equal to b into minus 1. Minus b. What about b? Both are minus sign. So you multiply minus on both sides, we get the value of b is 2. So b is 2. So the value of a is minus 1 and the value of b is 2. Now we substitute these two values in the first equation. You see, it is a first equation. There will be a constants a and b. So all the process is done only by to find the constants a and b. Now we use this value in the first equation. So 1 gives, what is the LHS of 1? X plus 1 divided by x plus 2 into x plus 3 is equal to a. The value of a is minus 1 divided by x plus 2 plus b. The value of b is 2 by x plus 3. The next step is taking integration. X plus 1 divided by x plus 2 into x plus 3 into dx. Actually, it is our question. So we consider the term, we split the given one. So partially, we split the fraction. So it is called a partial fraction. RHS also, integration of minus 1 divided by x plus 2 plus 2 divided by x plus 3 into dx. So I split in two integration. I will take outside minus 1 divided by x plus 2 into dx. In second term, the constant 2 is there, so I will take outside 2. 1 divided by x plus 3 into dx. We are using the concept of this partial fraction, so some formula shape is there. So that's why we use the partial fraction concept in this. Directly there is no formula, there is no simplification possible. We using this concept, this single term become split. So we split this two fraction. Now is exactly some formula shape. Minus. The integrating of 1 by x is log x. It is integrating of 1 divided by x plus 2 is just a constant. 1 divided by x plus 2. So its formula is log of modulus x plus 2. Actually, it's a composite function. Again, we are differentiating the term with respect to x. But the differentiating of x plus 2 with respect to x is just 1, so don't put 1. It's over next plus 2. So what is the integrating of 1 divided by x plus 3? Same, log of modulus x plus 3 plus c. So that is the answer. Suppose the answer is start from positive. So we write the first term positive term. 2 log of modulus x plus 3 minus log of modulus x plus 2 plus c. Again I tell you, in this sum, the word using partial fraction is not given. So now you have an idea depending upon our given sums. Now we move the next one. We integrate 1 divided by x minus 1 into x plus 2 the whole square. You see, I repeat a factor. One divided by x minus 1 x plus 2 the whole square into dx. Now integrate the term. You see the numerator is just 1 and denominator is a variables. Directly there is no formula. Suppose the term lies in numerator, we expand it, we multiply, we get one formula sheet. But all the term lies in denominator, so directly there is no integration formula. We solve the sum by using the same partial fraction. Now we consider the terms. Okay. What is our given sum? It's 1 divided by x minus 1 into x plus 2 the whole square. 1 divided by x minus 1 x plus 2 the whole square. I already tell each and every linear factor one constant. First of all, x minus 1 is one linear factor. So a divided by x minus 1 plus is a repeated factor. Square is there. What is the working rule? Plus b divided by, we write first of all the denominator, x plus 2. Again plus c divided by x plus 2 the whole square. Okay, square is there. We raise the power 1 by 1. Suppose cube is there, x plus 2 the whole square. Again plus d divided by x plus 3 the whole square, whole cube. So it is a working rule to write suppose a repeated factor, square cube like this. A maximum there will be power 3. Suppose power 3 is that plus d divided by x plus 2 the whole cube. Okay. The next step is to find the unknown constants a, b and c. How to find the unknown constants a, b and c? The same working rule. In previous one there will be just 2 terms. So just we cross multiply, we cancel the denominators. But you see here there will be 3 terms. Suppose 3 term is the 3 term become a single term. What is our work? So taking LCM. So what is the LCM of the denominator? X minus 1, x plus 2 into x plus 2 the whole square. In LCM we will be taking lower class in 10th also we see. Suppose we taking the LCM, we take the highest power. In GCD we take the least power. And x minus 1, x plus 2 and x plus 2 the whole square. So LCM of the denominator you identify. The LCM of the denominator is x minus 1 into x plus 2 the whole square. So I will take the LCM. So whole divided by x minus 1 into x plus 2 the whole square. So LHS is no change. We write as it is LHS 1 divided by x minus 1 into x plus 2 the whole square. Okay, now we see the first term a divided by x minus 1. But our LCM is x minus 1 into x plus 2 the whole square. What is the missing term? The missing term is x plus 2 the whole square. So the missing term is multiple with the numerator. What is the numerator actually? A. So a of x plus 2 the whole square. First term over. So we multiply the missing term. Plus next one is b. Plus b of the b denominator is x plus 2. But our LCM is x minus 1 into x plus 2 the whole square. So what is the missing term? 1x minus 1. In whole square only one term is there. So remaining x plus 2 is one term is there. So b of x minus 1 into x plus 2 I write. Because our LCM missing term is 1x minus 1, 1x plus 2. So b of x minus 1 into x plus 2. Okay. Next, plus c divided by x plus 2 the whole square. But it is a LCM. So the missing term is x minus 1. So we multiply the missing term to the numerator plus c of x minus 1. So it is a concept taking LCM. Okay. So we multiply the missing term to the numerated terms. Here also we cancel the denominator. All the denominators are same in both LHS and RHS. 1 a of x plus 2 the whole square plus b of x minus 1 into x plus 2 plus c of x minus 1. I put, suppose it is first equation. We put here also first equation. All this equation for our understanding purpose. So you don't use the equations. Suppose you know very well, you do one by one step. Now I put it as a first equation. Next I find the constants a, b and c using the values of x. So we put any values of x, but we need to find the value of the constant a, b and c. So first we see in which value of x we put, there will be two constants vanish. Is your choice. We put the value of x is minus 2. Suppose we put the value of x is minus 2, a is vanished, b also vanished, c value is there. Sir, suppose I put the value of x is 1, okay, b vanish, c vanish. To find the value of e, is your choice. First, I put the value of x is 1. So 1 is equal to a of 1 plus 2 the whole square. Whenever x is there, we replace x by 1. Plus b of, the value of x is 1 minus 1, 1 plus 2. Plus c of 1 minus 1. 1 is equal to a of 1 plus 2, 3 square, plus b of 1 minus 1 is 0, 1 plus 2 is 3, plus c of 1 minus 1 is 0. Is the first term, so I write elaborate. Suppose you understand the whole value is 0, we directly add 0. b into 0 into 3 is fully 0. c into 0 is 0. 1 is equal to a of, the value of 3 square is 9. What about a? The value of a is 1 by 9. So we find the value of a. The value of a is 1 by 9. Next, I use the value of x is other than 1. We find the constants a, b and c. So I already used the value of x is 1. Next, I use the value of x is minus 2 exactly here. Why? Suppose I use the value of x is minus 2 exactly. A is cancelled, b is cancelled, c only possible. So the next step is, I put the value of x is minus 2 in 1. So whenever x is there, I replace x by minus 2. So 1 is equal to a of, I directly write as 0. Minus 2 plus 2 is 0. 0 square is 0. 0 is everything is always 0. Second time also I write b of 0. Why? Is a value. But here minus 2 plus 2 is 0. Plus c of, the value of x is minus 2 minus 1. So 1, I leave these two terms. We have 0, we have 0. C of minus 2 minus 1 is minus 3. Minus 3c is equal to 1. C into minus 3 is a minus 3c is equal to 1. What about c? The value of c is minus 1 by 3. I find the value of c also. The value of c is minus 1 by 3. Next, to find the another one constant b. So a, c over. Next, to find the constant b. So using the both values is there. Just x plus 2 and x minus 1. So how to find the another constant b is there? Is our choice. We put any value of x. It may be a 0, 1, 2, 3 like this, any value. But the b is cannot be vanished. But one easy one work is that, suppose we equate the maximum power of x. Here maximum power of x is 1. What is the maximum power of x? We multiply, suppose x and x is x square 2. We expand x plus 2 the whole square. First time x square is there. So maximum power is square. So it is a easy work. Now we equating the coefficient of x square. Okay, we equate the coefficient of x square in both LHS and RHS. In LHS, what is the value? Just 1. So there is no coefficient of x square term is there. So coefficient of x square term is nil, so 0. In RHS, actually we expand first of all. X plus 2 the whole square, we expand, we get x square plus 4x plus 4, okay? A square plus 2ab plus b square. So one x square term is there. What is the coefficient of x square? Is a. So I write a. Next, here also. First of all, we multiply the factor. We get x square plus 2x minus 2. So coefficient of x square is just b plus b. Next, here there is no coefficient of x square term. So it's a new concept and also it's important. You see, coefficient of x square term equating means LHS and RHS, we write the coefficient of x square terms. In LHS there is no coefficient of x square term, so 0. In first term coefficient of x square is a. Second term coefficient of x square is b. And last also there is no coefficient of x square term, so 0. So I leave. So 0 is equal to, we substitute the known value. A plus b, we already find the value of a. The value of a is 1 by 9 plus b. What about b? So the value of b is minus 1 by 9. The next step, we substitute these values of this a, b and c. Okay, all these three values in this table. Okay, a, b, c. So we already find these three values. The next step is to substitute these values of a, b and c in this step and then taking integration. For understanding, I again write this word. Now to substitute the values of a, b, c in this equation. So 1 divided by x minus 1 x plus 2 the whole square is equal to a divided by x minus 1. The value of a is 1 by 9 by x minus 1. Actually plus b is there, but the value of b is minus 1 by 9. So plus and minus is minus 1 by 9 of x plus 2. Plus c is there, plus, but the value of c is minus 1 by 3. Minus 1 by 3 of x plus 2 the whole square. I write it is 1 by 9 of x minus 1, okay? 1 by 9 of x minus 1 minus 1 by 9 of x plus 2 minus 1 by 3 of x plus 2 the whole square. So the single term become now in 3 terms. The next step is taking integration. 1 divided by x minus 1 x plus 2 the whole square into dx. Now we integrate that all term. Integrating of 1 divided by 9 of x minus 1 minus 1 divided by 9 of x plus 2 minus 1 divided by 3 of x plus 2 the whole square into dx. For your understanding, I split this integration in 3 parts. In first one you see 1 by 9 is a constant, so I will take outside. 1 divided by x minus 1 into dx. This dx is common in all the 3 terms. Second term, how to write? Minus 1 by 9 of integrating of 1 divided by x plus 2 into dx. Directly is a formula, log of, so I write. In third one you see minus 1 by 3 of integrating of x plus 2 whole power minus 2. In denominator there is no formula of x plus 2 the whole square. So the denominator term goes to in numerator. We take outside minus 1 by 3. X plus 2 the whole square term suppose goes to numerator, it become x plus 2 whole power minus 2. Now we integrate 1 by 1 term. 1 by 9 of integrating of 1 divided by x minus 1 is log of modulus x minus 1. Again, minus 1 by 9 of integrating of 1 divided by x plus 2 is log of modulus x plus 2. Minus 1 by 3 of what is the final value of x plus 2 whole power minus 2 in integration? Using the same formula of x power n. X plus 2 whole power minus 2 plus 1 divided by minus 2 plus 1. Minus 2 plus 1 is minus 1. X plus 2 the whole inverse divided by minus 1 plus c. Okay, x power n formula, x power n plus 1 divided by n plus 1. Outside minus 1 by 3 is common. So 1 by 9 log of modulus x minus 1 minus 1 by 9 log of modulus x plus 2. Okay, what is the final answer of this one? Minus by minus is first of all plus. X plus 2 the whole inverse term suppose comes in denominator, it become x plus 2. So plus, I write it is 1 divided by 3 of x plus 2 plus c. Okay, I tell again, minus by minus is plus. 1 by 3 of x plus 2 the whole inverse term suppose comes in denominator, it become 1 divided by x plus 2. So 1 by 3 of x plus 2 plus c. So directly there is no formula. So first we using the concept of partial fraction. So in this class, first what is meant by a partial fraction and what are the types. So first you memorize all the 4 types, then we see the sums. What is the reason to use a partial fraction here? In integration directly there is no formula. Using the concept of the partial fraction, then we come one formula shape. So that's why we use the partial fraction concept here. But in our exam or test, the word using partial fraction is not given. So you must understand, we solve this problem by using the concept of a partial fraction.